In today's video lesson, we're going to learn about stoichiometry and how that relates to the mole and how it relates to balanced chemical equations. So balanced chemical equations tell us how many molecules of each reactant are interacting to make how many molecules of each product, but this also holds true for the mole. So the coefficients in a balanced chemical equation tell you how many moles of each reactant and product are interacting. So if we take a look at this particular chemical equation, we can see that it's not balanced. So first of all, we have 2 hydrogens on this side and 2 on the product side. So that's fine. The oxygen, there's 2 on the reactant side, but only 1 on the product side. So we'll need to put a 2 here. And then that will throw off our balance for hydrogen. So now there's 4 on the product side, so we'll need to put a 2 here to make 4 on this side. So what this equation is telling us is that 2 molecules of hydrogen interact with 1 molecule of oxygen to make 2 molecules of water. It's also telling us that 2 moles of hydrogen will interact with 1 mole of oxygen to make 2 moles of water. So these ratios are very important in the concept of stoichiometry. So just like we said already, 2 molecules of hydrogen gas are reacting with 1 molecule of oxygen gas to make 2 molecules of water. So if you take a look at the ratio, it's 2 to 1 to 2. You can multiply those ratios to find the ratio of larger quantities or even smaller quantities by dividing the ratio. So if we wanted to know a larger quantity, if you multiply everything in the ratio by 3, that would mean that 6 molecules of hydrogen are interacting with 3 molecules of oxygen to make 6 molecules of water. So that's kind of the starter lesson on how stoichiometry works. So what if we wanted to make 26 water molecules? Well, we could use some proportional reasoning like we learned in grade 9 math. And we could multiply the 26 water molecules by a conversion factor to find out how many hydrogens and oxygens we need. Because that conversion factor would be a ratio that shows the relationship of molecules in a chemical reaction. So first of all, we need to remind ourselves of the ratio. So we have 2 hydrogens to 1 oxygen to 2 waters. So if we wanted to know, so we know we have 26 waters, that's what we want, so we want to know how many hydrogens we need. Well, the ratio of hydrogen to water is 2, so there's 2 hydrogens for every water, so for every 2 waters, so we can cancel this out. So 26 times 2 divided by 2, that's just going to be equal to 26 hydrogens. So if you wanted to make 26 water molecules, you'll need 26 hydrogens. But now we'll do the same thing with oxygen. So when we set up these conversion factors, the thing that you want to find out, you need to put on the top of the ratio. So this one, the ratio of oxygen to water is 1 oxygen to every 2 waters. So we can cancel out the waters. So this time we're multiplying it by a half. So it's going to be 13 oxygens. So if you needed to make 26 water molecules, you would need 26 hydrogens and 13 oxygen molecules. So that's how stoichiometry works.